Example 2, we are given a little bit more vague information. We don't have a point to plot, but we do have 2 hints of where this angle is going to live. So if I'm going to find trig functions, I want a triangle. I want opposite, adjacent, and hypotenuse sides. I want to be able to plug them into the formulas that I know for the trig functions. So I'm going to get a triangle, and because I am given specific information about tangent and cosine, that should be enough with those clues to draw the angle and make it a triangle. So first, I know that tangent is -5/4. If you go down here to our little chart, tangent is going to be negative in quadrants 2 and 4. So I know that the angle I'm dealing with is either in quadrant 2 or 4. Then it says that cosine is positive, so that is here and here. That's in 1 and 4. So I'm looking at the one that has both of those in common, and that would be 4. 4 has cosine being positive and tangent being negative. So I'm going to say that this angle for this problem is in quadrant 4. It allows me to graph it accurately. It can be anywhere in quadrant 4. I'm just going to put the terminal side there, but anywhere in quadrant 4 would work. Now I'm going to make it a triangle by taking my point at the end, going straight up to the x-axis, make it a right triangle, and create a triangle. The angle that I'm going to reference is here next to the origin, and then I'm going to fill in all the side lengths with the information that I'm given. So tangent is -5/4. That means it could be -5/4 or 5/-4. Right now I'm not sure, but as I fill in my side lengths, I'll be able to figure that out. Since tangent is y/x, I know that the 5 goes with the y and the 4 goes with the x. So as I look on my triangle, this is over, so this is my x, because it's how far it is on the x-axis, so that would be 4. And then this is down, this is how far it goes down on the y-axis, so this would be y, and that's 5. If you look here, this one is over to the right, that's a +4. This one is down, so that's a -5. So by graphing the angle in the correct quadrant, I'm able to figure out where that negative goes. Now I would have to find the hypotenuse. I'll do that using the Pythagorean theorem. It would be 4 squared plus -5 squared equals c squared. 16 plus 25 is 41, so c is square root of 41. You can call it r, you can call it c, you can call it h for hypotenuse, but that is the missing side that I needed. Now when I find the 5 remaining trig functions, I've got my opposite, that would be here, I've got my adjacent, that would be here, I've got my hypotenuse, or I can use x, y, and r. Either will work. So the 5 remaining trig functions, that would be sine of theta, cosine of theta, tangent of theta. Tangent we already know, so it's a guinea. Cosecant of theta, secant of theta, and cotangent of theta. So cotangent's the easiest. It's just the reciprocal of tangent, so that one's done pretty quick. Sine is y/r, so it's -5 over square root of 41. I'll simplify that in a minute. Cosine is x/r, so that's 4 over square root of 41. I'll simplify that in a minute. Cosecant is a reciprocal of sine, so I'll flip sine, and that would be negative square root of 41 over -5. Secant would be the flip of cosine, so it would be square root of 41 over 4. So that one's done. And the last thing I have to do is simplify these or rationalize the denominator because they have a square root on the bottom. So I'll multiply by square root of 41 over square root of 41 to get -5 square root of 41 over 41. Here I have to do the same thing. I have a square root on the bottom, so I'll multiply by square root of 41 over square root of 41, and I get 4 square root of 41 over 41.